Here we're talking about understanding polynomials. And students hear the term polynomials and they're like, holy cow, how is this even a math term? Sounds like something we would talk about in English class. And what I usually tell my students is don't make more of it than what it is. All it is it is a mixture or a combination between the numbers that we know and these things called variables, our letters. Okay, this is the point where math became no longer fun, am I right? I have a brother that told me that, tells me all the time. He struggled with math. He's like, yeah, I was doing fine until they decided to put the letters with the numbers. That's when it became confusing. So, but again, we're not going to make more of it than what it is. A number or a product of numbers and the variables mixed with those whole numbers, okay, that is a polynomial. It's actually a monomial. Sorry. Monomial is a single term. It could be the following. It could be 4x. It could be negative 3xy squared. It could be 7. All of those are examples of monomials. Actually, let's go 7a. When we take these single terms and we put them together with plus or minus signs, this is where we start to create polynomials. So if we wanted to, we could take all of our previous monomials, 4x minus 3xy squared plus 7a, and there is an example of a polynomial. Again, you don't need the definition. Okay. Maybe just the examples, if anything else. Another term that we need to talk about is when we work with multiple terms, we like to put them in what we call standard form. Standard form is when we, first of all, we need to simplify the expression if we can. Look for those like terms if they exist. And then what we like to do is put them in descending order, which means we start with our greatest degree and work down to our least or constant term if it exists. So here's a look at a polynomial. This is in standard form. How many terms do we have up on the board? 4. Yep. 1, 2, 3, and 4. Okay. Standard form because we start with the highest degree, which is the exponent, and we work down to our smallest. Okay. Couple of things that we need to identify. Let's start with this thing called a leading coefficient. This would maybe be a good one to put in your notes. So here's the example. First thing they're going to ask you to find is this leading coefficient. We think of leading, we think of at the beginning. And coefficient is nothing more than a number. So what's the leading number? Well, it's this one right here, which is understood to be a -1. So the leading coefficient is -1. Students will always write this down. They'll go negative x to the 4th. It's, yes, I'll give it to you, but understand this is the leading term. I just want the leading coefficient, which is just strictly the number. Number of terms. They'll ask you for that. How many terms are there in the expression? Here there are 4 of them. They're going to do this to you though. How many terms are in this expression?
2.
Good. Okay. A lot of people will write 3. 1, 2, and 3. The only problem is we need to simplify this thing first. Okay. Once we simplify, now we're down to 2 terms. The other thing that we need to be able to identify is this thing called the constant term. And the constant term is the term that does not have a variable next to it, which in this case is this positive 2 at the end. 2. Understand, not every expression is going to have a constant term. You could have this expression. let's say we put an x there. This one doesn't have it. We could say the constant term is 0. I guess we could say it's plus 0. So you can either write constant term is 0 or does not have one. So let's go ahead and do that for example number 1. So they're going to give us a polynomial. We want to write it in standard form. We want to identify the leading coefficient. We also want to identify the constant term. So first things first, I always start by identifying the highest exponent, which is going to be 2x to the 5th. And it's a positive 2x, so I move it out, or I keep it positive. Next thing I notice is my next highest exponent is 2. But I also notice that I have 2 of those. I have this one and this one plus 3x squared. What comes next?
X.
So times x minus x.
Plus X.
Yep, plus x, it's a positive x. And minus 5. There it is in standard form. We have grouped our like terms together. You know how to do that. Descending order, 5, 2, 1, constant term. Leading coefficient, you can just go LC if you want to. I don't know what you're talking about. What would that be? Cole?
2.
Constant term, Morgan?
Negative 5.
-5. Good so far? This is one you may want to put in your notes. I understand it's a rather large table. So I'll give you a head start with it. Okay to move on? Alright, let's start filling this thing out. Degree. They're going to ask you to identify the degree. So let's begin there. Degree is the highest exponent. If we go back to this example here, what's our highest exponent? 5, therefore the degree is 5. It's as simple as that. So, let's start with this one. -4. This is kind of a tricky one. 0, yeah. Notice we don't have a variable. We could, if we wanted to, we could view it as this, because what's x to the 0? 1, so we're okay. But here your degree is 0. What's the degree here? 1. Degree here? 2. 3. Here the degree is 4. Here our highest degree is 5. Degree is the highest exponent. And from the degree, now we can go ahead and classify it as something. Okay? If you go back to your triangles, if you were classifying by the angles, you had acute, obtuse, and right. If you were classifying by the sides, you had scalene, isosceles, and equilateral. It's the same concept with polynomials. Not only can we classify them by the degree, but we can also classify them by the number of terms. Why don't we classify by the number of terms first, because I think that's the one you're most comfortable with. Your options are monomial, binomial, and trinomial. Monomial again means 1 term. Binomial means how many terms? 2. And trinomial obviously means 3. So, -4, monomial. X plus 2, how many terms do we have? 2, hence binomial. Next one has 3 terms, hence trinomial. And I will never ask you to identify any terms greater than 3. So those are always going to be your 3 options if you're classifying by number of terms. What's the next one? Monomial. Trinomial. Students always get those right. The ones that we struggle with is when we classify by the degree, because we're dealing with names that some of them we've heard of before and some of them we have not. If our degree is 0, we call this the constant term. So this is classified as being constant, where it is a constant expression. X plus 2. What figure did this always create when we graphed it? Yeah, it's a line, so it's linear. So linear. You worked with these a little bit with Mr. Emery. In fact, quite a bit. It was called a quadratic. Exponent of 3. Any guesses? Cubic. Degree of 4. That is called a quartic. And degree of 5 is quintic. So 4 and 5 are really close to one another. When we put both of these ideas together, if I look at this one, I could call this thing a quintic binomial. By labeling it those 2 things, I know one of 2 things. Number 1, the highest degree is 5, or the degree is 5. Also, we're only looking at 2 terms. Let's go ahead and move on. Let's go ahead and do so then. If we classify by the degree, a lot of you will put 2 because the exponent is 2, but that's not good enough. Okay, I want you to actually say the name of it. So, if the degree is 2, what's the name of it? Quadratic. And if we classify by the number of terms, we have 2 of them, binomial. about B? What's our highest degree?
5.
Yes. And maybe, well, let's go ahead and do that. Degree is 5, so if we go back to a chart, degree of 5 meant that it was called a quintic. About the number of terms.
3.
Good. Okay. Again, you caught on to the fact that those two are like terms. If we write this thing in standard form, which they will ask you to do, minus x cubed plus x. So the number of terms, 3 of them, trinomial. We can add polynomials together. And essentially when you're adding, if we look at the inside of the parentheses here, is there anything we can collect? No. Is there anything that we can collect inside this set of parentheses? No. So essentially, if you can't simplify inside the parentheses just go away. And now you're just playing the match game. Mr. Doerr's version of the match game. The game changes slightly when we subtract because something takes place here. What happens is this minus sign or that subtraction sign now plays a role. And the way I like to view it is essentially we need to multiply the polynomial by -1. Other way students like to refer to it as is they are just flipping the signs of the terms on the inside. So if we do that, 5x cubed minus 3x squared, and if we distribute the negative, this 2x cubed becomes negative 2x cubed, positive x squared minus 4. Be leery of the minus sign in front of the parentheses. It is no different if you have this. That means it would be -4 or negative x plus 4. Same thing, same concept. And just for comprehension's sake, let's go ahead and see if we can identify these. Classify by degree and number of terms. If we classify by the degree, what would this one be? Cubic. And cubic trinomial. Cubic trinomial again. Yeah. Very good.